All right, we're going to get into some problems with angles, okay? We're going to spend a solid week, maybe a week and a half on angles. All right, angles and arcs are both measured in degrees. That's really important. All right, so we're going to talk about two types of angles today. Central angles, inscribed angles. All right, these are two of like 5 or 6 different types. The central angle is equal to the measure of the arc. I'm going to just write the opposite arc. So if I'm looking at angle, the 75-degree angle here, it equals the arc that's opposite. So this arc is 75. Now, this comes into play once in a while. Think about a circle. A whole circle is 360 degrees. So sometimes they're going to want you to find the other part of the arc. So this is the minor arc. If they ask for the major arc, think about it. From here to here would be the rest of the way around the circle. So if I wanted this arc, it would be 360 minus 75, which would be 285. So let's say I called this A, let's say B, C. Arc AC would be 75, but arc ABC, the major arc, would be 285. All right? The other type we're going to talk about is an inscribed angle. The inscribed angle is half of the arc. So if I want this angle, it's half of this arc here. So half of 150 degrees. All right, and these are the two relationships we're going to look at today. All right, I'm going to go over a couple more examples. All right, sometimes they get a little tricky. All right, this one wanted you to find the measure of angle. It got cut off. Arc, let's say FCD. I think it was BCD. All right, I don't know what happened to the picture. All right, so something you should notice. Okay, this arc is going to be equal to this central angle. This one's 81. Okay? This arc is going to be equal to this central angle. So arc FB is 135. Now, what's happening here, which is slick, which you may not have noticed, is this chord goes through the center. So this whole thing is half a circle. So this arc, or whole thing, FBC, is 180. So if I wanted this piece, it's going to be 180 minus 135, or 45 degrees. So this arc here is 45. All right? And then if you wanted, let's say, BCD, right, this is half the circle also, because this is the diameter. So if I wanted this arc, it's got to be whatever's left out of the 180. So if I add 81 and 45, and then subtract from 180, arc BCD is 54 degrees. All right? There's not going to be many problems with central angles. They're going to be more of the other ones like the inscribed angles. Okay? All right, so number 2. They want you to find this angle. And again, you got to watch out. They gave you the diameter. So that means this arc is half of a circle. So this arc is 180. But they gave you this piece, AC. Arc AC is 92. So if I want this arc, it's going to be 180 minus 82, which is going to be 88 degrees. So arc CB is 88 degrees. They want this angle, though, and that's going to be half of that arc. So X is going to be 88 divided by 2, or 44 degrees. All right, and that's what many of these questions are going to be like. All right, 5 and 6, again, are similar. All right. I'm sorry, 3 and 4 are similar. I'll let you try those. But let me get to some that are going to be a little trickier on this next page. All right. Let's take a look at, say, number 8. All right. Again, they're trying to get A little sneaky here, but it's not as bad as it looks. All right, they're giving me this angle, 42 degrees. I want to know what arc VW is, and I want to know what arc WX is. All right, VW is real easy. Remember, this angle is half of this arc. So if I want this arc, it's going to be twice this angle. So 2 times 42, WV is going to be 84 degrees. They want to know WX, and if you look, that forms your half circle. So if I want WX, it's just what's ever left out of the 180. So WX is just going to be 180 minus your 84, which is going to come out to 96 degrees. All right? So it's not as complicated as it originally looks. All right? All right. Let me show you another one with a triangle real quick. All right? All right, number 9. Find the measures of all the missing arcs. All right, again. This one's formed by this inscribed angle. So this one's going to be, remember, the angle is half the arc. So if they give me the angle, the arc is going to be twice the angle. 2 times 49, 98 degrees. So arc BC is 98. All right, again, I have a pencil. I'll show you this one. Arc DB is formed by angle C. See how angle C connects on both ends from B to D? So angle 70 is an inscribed angle. It has to be half this arc. So if I want the arc, it's just double 70 or 140 degrees. And if you look, the only arc that's left forms the whole circle. So if I want this last one, I'm going to add 140 and 98, which comes out to 238. And then this one's just going to be 360 minus 238, because all the way around your circle is 360 degrees. So this arc, 122 degrees. All right? Why don't we look at number 10, and then you can check these out. All right? All right, number 10, a little trickier. All right, this angle H is inscribed. Notice H is formed by these two. It goes from G, and then the other segment that forms the angle is H to V. So this arc, we could find out. It's going to be twice this 65. So that arc's going to be 130. All right? Then, this 119 is formed by FV and VH. So from here to here, all right, is going to be twice that 119. Which is going to come out to 238. But if you notice, okay, it's 168 from here to here. So this part from F to G is going to be 238 minus 68. So FG is going to be 70 degrees. And GFV, we already found out, was 130 degrees. And then if you really wanted to get VH, which I'm not going to go wild with, it's just going to be the rest of it around. So if you added it all up and subtract from 360, you would get VH. But we're not going to go too crazy there. All right? This gives you an idea of what these problems are like. Try the rest of these, and we'll hit some other angle relationships tomorrow.